Now the today topic is wet granulation. Today's topic is wet granulation. why why we need to do wet granulation means when the compatibility of powder is less, when the compatibility of powder is poor, then we need to increase the flow. We need to increase the flow. We need to increase the cohesion. See, flow means the particle is not moving properly, not moving properly. We need to increase the flow, increase the flow. Next, cohesion. See, in between the two particles, the force, attraction forces are weak. We need to make strong attractive forces by increasing the electrostatic and van der Waals attractions. Next, increase the segregation. So what we need to increase the flow, increase the cohesion, and increase the segregation. In case of the powder having poor compatibility, then what is the flow means? This is irregular pattern of movement of a particle. Then I need to make means smooth flow. This is called as a smooth flow. Smooth flow of particles. I need to make the irregular movement of particle into the smooth flow. Then increase the cohesion. So initially the weak forces are there between the particles. Weak forces are there. I need to make strong electrostatic and van der Waals forces. I need to increase the electrostatic and van der Waals forces. Next, I need to increase the segregation potential. I need to increase the segregation potential. What is the role of increasing the segregation means? Whenever you put or whenever you take the tablet, it will enter into the GIT, gastrointestinal system. Then the particles need to disintegrate, means that whatever the granule is present, that need to disintegrate quickly and lead to segregation, means separation of granules or disintegration of the tablet or separation of granules. For that, we need increase the segregation. We need increase the segregation of granules. So next one. So what are the stages? What are the stages of wet granulation means? Pendular state. See, little amount of liquid is there. This liquid bridges are binder. These liquid bridges are binder. Nothing but binder. Now, this binder binds two particles. This will bind the particles. This binder binds the particles. Liquid bridges are called as a binder. See, pendular stage, funicular stage, capillary state, overweighted or droplet state. Overweighted or droplet state. In pendular state, what will happen is there is a formation of liquid bridges. Formation of small liquid bridges. See, small liquid bridges are formed. Now, what will happen in funicular state? Next stage is funicular stage. So there is increased amount of binder here compared to pendular stage. There is increased amount of liquid binder. See, here only one choppies of thickness is there. Here two choppies. See, two choppies or three choppies of thickness means the binder concentration is increased here in case of funicular state. And then compare, this is empty space, these are the empty space. There is a more amount of air is present here. Here less amount of air is present. Comparatively or relatively, more amount of air is present, here less amount of air is present. Next, capillary state. No air, see, not at all, nothing air is present in the capillary state. This is our desired state for the formulating of the tablet. This is our desired state in order to formulate the tablet. No air is present because no air is present. If air is present means it's cause like capping, entropiment of air, different properties. Means it will affect the tablet strength also. Next, overweighted means see the liquid binder is surrounded by all the particles, completely surrounding of liquid binder we can call as a overweighted or a droplet state. This droplet state is not at all acceptable. The droplet state is not at all acceptable. Pharmaceutically unacceptable. It is due to how this is formed is due to improper drying or mixing. Due to improper drying or mixing leads to the overwetted or droplet state. In overwetted state, what will happen if you formulate? See, if you are using this state of granule in order to formulate the tablet, what will happen? See, more amount of binder is there. This more amount of binder will reduce the dissolution. Dissolution means separation of the particles. Separation of the particles. Decrease the dissolution and disintegration. Decrease the dissolution and disintegration. This will decrease when more amount of binder is present in case of overweighted or droplet state. This is completely pharmaceutically unacceptable. Which is pharmaceutically acceptable? This capillary state is pharmaceutically acceptable because no air is present. So at what stage? This capillary state we can obtain by spray or tray drying. By spray or tray drying, we can obtain this capillary state. Next, this is overweighted. Next one is underweighted. Overweighted droplet stage. Overweighted the particles. Here, underweighted. What are the two? Pendicular and funicular states are underweighted. Means less amount of binder is present in these cases. So, if you will formulate the tablet by using this pendicular or funicular state, what will happen means granule will disintegrate during the mixing, means during the manufacturing of tablets. The granules means this underweighted granules will disintegrate. When you will mix, subsequent process are there in the tablet manufacturing. When you will use this state means this pendicular and funicular state will disintegrate, means due to presence of less amount of binder, the particles will disintegrate immediately during the subsequent processing of the tablet. So not preferable. Pendicular funicular states are not at all preferable. Capillary state only preferable. Overweighted not at all preferable. These are the different stages of wet granulation. Next one is binder. See, for what purpose we are doing drying in case of wet granulation means binder solution. We are not using binder. For example, if you consider the polymer, this is a polymer, you need to dissolve this polymer into the water system. Then you need to use it as a binder. So binder solution nothing but polymer plus solvent. So we need to dissolve the polymer into the suitable solvent, that is either water or alcohol, organic or either water or alcohol. A proper solvent we need to dissolve. So what will happen? So we no need this solvent. We no need this solvent present in the capillary stage. This is pharmaceutically acceptable. So we no need this solvent. So how can we remove this solvent? Means by using, when you will dry, spray dryer, tray dryer, then the solvent will evaporate. This alcohol will evaporate quickly compared to water. Alcohol evaporate quickly compared to water. Hence, the solvent which is present in the binder solution can be removed by using drying. So this is about the wet granulation. Increase the flow, increase the cohesion, increase the segregation of the particles in GIT. So these are the different stages of wet granulation.